Hello, in this video I'm going to introduce you to continuous integration and continuous delivery, CI/CD, and also explain how your organization can benefit from that process. When it comes to software development, there are several rules needs to be followed to ensure the integrity of your source code and application. Source code should be stored in the centralized repository with the version control support. For example, Git, Subversion, Mercurial. There are multiple services allowing you to store the source code on a cloud, such as GitHub or Bitbucket. But you can also host the repository locally if it is required. Code stored in the repository must be compilable on any machine. It means that it should be self-contained and include any references which are required to build that project. Of course, it doesn't mean that the compiled application will be operational on that machine, because it might require some additional environmental settings or some additional third-party applications. Code should contain unit tests which should ensure the integrity of the functionality of the application. There shouldn't be any secrets stored in the source code, such as credentials, connection strings, or certificates. Otherwise, you can compromise the integrity of your system if third-party having access to the source code. This could happen unintentionally, for example when you invite third-party developer to collaborate in your project. When it comes to delivery, it is required to assign the unique version for your package. The product should generate an installable package, so your QA team or customers can easily deploy it on their machines. I would categorize those 4 steps into the integration stage and those 2 into the delivery stage. Ideally, this process should be repeated after every commit. And as you can imagine, it could be quite time-consuming and prone to errors. And this is where the continuous integration and continuous delivery, or just CI/CD practice would come into the picture. So you can fully automate that process and separate the responsibility in your team. So your developers will commit the code frequently, QA team would have a test installers as often as possible, and your customers will be able to receive a new package when manager approves the release. There are many cloud and in-house systems allowing you to set up CI/CD. That includes but not limited to Jenkins, Hudson, Microsoft Azure DevOps, GitHub Actions, Bitbucket, etc. Most of the software development companies do have this process implemented in their workflow. However, it is not the case for the other companies, who might have their own in-house developed tools to support their business processes. Such companies usually have either 1 or 2 developers, or they might not have developers at all, and this role is assigned to the employees who have some development skills. Usually that product plays a major part in their business workflow. However, it is a big risk to lose that product or lose the knowledge if the CI/CD process is not set up. I have explained that situation in a little bit more details in my blog post. Please follow the link in the description of this video. You can also contact us by sending an email to info@xerial.com for free assessment and quote of setting up the CI/CD pipeline in your organization. Now I want to demonstrate you a practical use of CI/CD. I have a product called CAD Plus Toolset, which is a plugin to SolidWorks and providing some additional functionality for SolidWorks. The source code is hosted on a GitHub, and CI/CD is set up on Microsoft Azure DevOps. In my development process, I have 2 main branches. First one is the master, which stores the production code. Another one is the dev, which stores the intermediate code. When code submitted to dev, it is assumed that certain functionality has been completed. So now it is possible to build a new preview version of the product and test by QA team. In the first demo, I'm going to show you the scenario where the features are committed directly to the dev branch and in the end merged to the master. In this scenario, the continuous integration and delivery pipeline will be started automatically whenever new commit is added to the dev branch or the master branch. Although this process could be acceptable for the certain types of commits, it can be cumbersome when working in the teams. At first, it might unnecessarily trigger the pipeline when you just want to save your current job and not really finish the feature yet. Secondly, you risk in submitting the broken code into one of your main branches. And until the pipeline is run, issues detected, and you have rectified it, you might have a broken code in your repository. So usually this approach can only be acceptable if there is only 1 developer on the project at a time. I will show you the alternative approach which addresses those issues in the second demo. Build pipeline will perform the following steps automatically on each commit into the dev or master branch. It will compose the package version and assign that to installer and all the libraries in the package. I will explain a little bit more about the versioning scheme in a moment. Pipeline will check out the latest source code and compile it. It will run unit test, then digitally sign all executable files produced as a part of the build. Then it will build an MSI installer and also digitally sign that installer. Then it's going to deploy the installer to Microsoft App Center. For the code submitted into the dev branch, it is going to build the preview installer and submit to the corresponding group in the App Center. So for example, that group can be visible for your QA team only. When code submitted to master branch, it is going to compile two installers. First one is a pre-release and it put it into corresponding group in the App Center. And another one is a production release. But this release will not be published automatically until it got approved manually by the manager. Now just a quick explanation of the numbering scheme I'm using in my organization. This one is a major version, this is a minor, and this is a revision. And this is assigned by the JSON file in the source code, and this is usually assigned by developer when new feature is about to be released. This number here is a build number corresponding to the run of the pipeline on Azure DevOps, and this gets assigned by the build server automatically. And this number is an index indicating the type of the build. For dev builds I'm using 4, for pre-release builds I'm using 8, and for production releases I'm using 9. Let's start with this simple issue, and this one is just regarding the incorrect icon for the application. So application is export, which is doing the batch exporting through eDrawings, and the icon used here is looking like properties icon. So if I would fix that problem, I would have an icon like that. Now I simply need to increase the version of my software before pushing to production. Because it is a very simple fix, I would only increase the revision. Perhaps in real life I would not push that build into production with just that issue fixed, but for this demo I'm just going to do that. So I'm just going to increment the revision and I can push the code to my Git repository. As a part of this first push, I want to deliberately exclude one of the files, so my build is going to fail. So let me not include my icon. It is also beneficial to use the ID of the bug in the comment, because GitHub can pick it up and automatically close the ticket once it is merged into the master. Because my pipeline is automatically triggered when I'm pushing the data into the dev or master branch, you can see that new run has been started. I can navigate and see what is going to happen. So there are multiple steps to build this pipeline. So it's going to check out the code, it's going to try to compile that. And as I would expect, that particular step has failed because I'm missing the file and my build has not succeeded. I can click on the failed step to investigate the issue closer. So you can see there is some error regarding the missing file. So let me come back to my Visual Studio and fix that issue. To fix this issue, I simply need to commit my missing file to Git repository. So I'm going to commit and add that file and add the message. Now the code has been pushed and we can navigate to our Azure DevOps to see the pipeline. Of course, normally you would not monitor your DevOps every time you push the build. Rather, you will receive a notification via email or any other option you set up when build failed or succeeded. We can click on that build to see more details. So you can see my pipeline is set up the way that it firstly builds the application, does all the necessary steps to validate the code, and then it either publishes a preview version or production version. So not only it builds the code, but it also runs an automated unit test to validate the functionality is correct. So in this case, I only have one unit test, which has been successful. Once the build stage is completed, the pipeline moved into the deployment stage. Because I have pushed the code into the dev branch, this is going to be published to my preview version. And as part of this pipeline, I'm going to publish my installer directly to Microsoft App Center. Once I refresh this page, you can see the new installer is available for download. I also want to point out that pipeline automatically created a versioning for that deployment, also included the preview word indicating this is a preview build, and you can see that the ID of the build is contained in the version of that installer. Now we can download and install that application on our computer. Pipeline has also automatically digitally signed that installer, so you can see that publisher is validated. Let me just quickly install that application. We can now start our application to validate the result, and we can see that icon has been replaced correctly. This is usually done by QA team. Let me now quickly navigate to the installation directory and show what else has been done by pipeline. So as a part of that pipeline, all the executables are automatically signed with a digital signature. And also all of the files have been assigned the version, so I can easily track that application if I need to. So you can see that this DLL has a correct version, and also the executable as well has the same version. Now, assuming that I'm happy with the result, I can merge a change directly into the master branch, which is going to trigger our production pipeline. I first need to activate the master branch and merge my dev branch into master. Once it has been done, I can commit the change, I can specify the message. So for example, I'm just going to indicate this is a release of version 0.1.1 and click commit. Now the production pipeline has been triggered, and as a part of this pipeline, it's going to deploy two installers. One is a pre-release version, which is going to be published to Microsoft App Center in the same repository as our preview version. Another one is a production version, which is going to be also published in App Center, but in the different category, which is a production category. In addition, the installer file are also accessible via artifacts. So your team could access those files by navigating into the artifacts URL and downloading those files directly. Now you can see that our preview deployment is in progress, while our production deployment is waiting an approval. This is a specific setting I have set up as a part of this pipeline, so I can only release an installer into production once it has been approved by QA team, for example. The preview deployment is complete, and I can just refresh this page and you will see a new installer available for download. But you can see it is now named pre-release. We can now download that installer and run tests. The way versioning is set up, every new installer will have a higher version, which means that you can simply install and update an existing installation. So I can just follow my installer to update my installation. The version is also available in the controls panel of the installed product, so you can see it's here. Let's now quickly validate the result before approving that request. So icon is here, so we assume that it is working correctly. Usually it will take way more time to validate that result, but as part of this demo, we're going to just approve that request to push that build into production. Production deployment is complete. Let's refresh the page of preview deployments, and you can see there is no new file appearing here. But if I refresh the production deployments, you can see there is a new installer available. So this is something which is going to go to customers. So we can also just download and just do last testing to make sure that this is workable. And after that, we can notify about release. Let's start the application, and we can see that it started correctly and icon is correct. I also want to show that those pipelines run are grouped under the preview and production environments, so you can easily find which run corresponds to which environment. Another interesting feature of GitHub is that ticket was automatically closed once I merged the changes into the master. And you can actually see which particular commit resulted in fixing of this bug. In the next demo, I'm going to demonstrate similar process but with a different branching schema. I still have the same two main branches, dev and master, But now, instead of committing the code directly into the dev branch, I will create another branch of the dev branch and call it after the feature name and going to do commits there. In this scenario, I can commit any code to my branch and it's not going to compromise my main branches. In my pipeline, I'm not going to automatically test this branch. However, if I want to, I can do that as well. When I think that the development of that feature is complete, I now need to integrate these changes into dev branch. But rather than merging that directly, I'm going to create a pull request, which is not going to be merged until it is got approved. Once it is reviewed and approved, it's going to be automatically merged into the dev branch. I can repeat similar process and create a pull request to integrate changes from a dev branch into the master. And once that request is approved, the changes will be merged into my master branch, and this will trigger the pipeline and produce a production build. Here is another bug which I have already fixed, and I have fixed that in a new branch called export. So let me just do a few changes. So firstly, I'm just going to increment my version, and this is a bigger change than the previous issue, so I'm just going to increment the minor version instead of the revision. So in a similar way, I'm just going to say that minor is going to be 0.2 and my revision is going to be 0. Okay, so another thing which I'm going to show you is I'm just going to comment a couple of lines here which show the result of my operation. Although this is not resulting in the build error, it actually results in a functionality error. And on this project I have unit test which is going to tell that. So I'm just going to show you how that works. So let me push the changes into the branch. I'm just going to show which issue I have fixed and push that. In this pipeline, I haven't set up to build every branch, rather only build dev and master. Of course, in your situation, you might want to build all the branches you push. So you can see a new run has not been started because I only pushed to export branch. So what I'm going to do now is to create a pull request of that change to be integrated into my development branch. So you can see GitHub already given me a hint, so I can just proceed, select which branch I want to integrate to, can specify some comments, assign the reviewers, assign the people responsible for that request, so in this case it's going to be myself, and click on Create Pull Request button to create a pull request. Pull request will not push the changes until they are approved. And because I'm going to integrate those changes into the dev branch, GitHub will automatically run the pipeline to make sure that the changes I'm about to integrate are actually valid for the dev branch before it gets integrated. This is extremely important because it will ensure that all the changes I'm pushing into the dev branch are valid. It is in particular useful if you have a team of several developers, because they would usually integrate the changes from a dev branch into their working branch before proceeding with their implementation. And having a compromised code in the development branch might result in issues of the development process. As you can see, GitHub has found that changes I'm about to integrate are not valid. So let's just investigate what the problem is. We can follow links, and we can see that not all of our unit tests have been successful. We can click and we can see more detailed explanation of an error. Unlike previous demonstration, that build was successfully compiled, but our unit tests have failed. Of course, usually before you pushing the code, you would run the unit test locally. So if I go to my test explorer, click on run unit test, you will see that this error is reproducible on my machine as well. So I can navigate to the test and investigate more closely what the error is. Because of this demo, I don't know what the problem is, so let me just uncomment those lines, run my tests to make sure that they're now correct. So now all the tests have passed and I can just push the change into my Git repository. I can specify the message and click on commit. So now GitHub will automatically pick up a new build and reevaluate the checks. I can switch to pull requests tab to see my pull request and its progress. Checks are currently re-evaluating. I can switch to my pipelines view and see that new pipeline has been started. I also want to point out that the pipeline run when pull request is made does not involve the deployment stages, so it only does the build and unit testing. Once the validation is completed, I can now see that my pull request can be merged. So I can simply click a merge pull request. I can specify the message if I want and click confirm merge. So because now that code has been pushed into my dev branch, this would trigger my deployment pipeline. Similar to previous steps, it's going to automatically compile, create installers, and submit this to Microsoft App Center into the preview environment. If you navigate to the preview tab of App Center and refresh the page, you can see that new installer is available for download. Now we can process similar steps and create another pull request to integrate the changes from dev into our master branch to create a new production installer. GitHub will run similar validation checks, and once it is complete, we can simply approve our pull request. Once changes are integrated, this will trigger another production pipeline. So it's going to build the project, it's going to publish our pre-release version, and it also will wait for approval of the production version. We can review this new version and approve it. And the new version of an installer is published to the production group of Microsoft App Center. Thank you for your time.